Let's take a look at the clocking for the CPU in Multicomp. Grant's got a little piece of code here that's got a counter in it for the CPU clock count, and when you want to run at 10 megahertz you set that CPU clock count value to 4. If you want to run at 12.5 megahertz you set it to 3, and basically it's the 50 megahertz divided by number with plus 1 added to it, because he's doing a less than for the comparison here. So 4 plus 1 is 5, 50 divided by 5 is 10 megahertz, and 50 divided by 6 and 7 and, well, excuse me, divided by 5 and 4 and 3 and 2 give you 10, 12.5, 16.6, and 25 megahertz. Right now it's set up on the 6809 to run at 10 megahertz. The next bit of logic here takes that clock count and flips a clock bit every other time. If it's 4, it does it with 2. So it creates basically a clock, a 50-50 clock in the case of 10 megahertz, but it creates symmetric or asymmetric clocks, I think, in the other cases, although the 25 megahertz would be in every other clock. So basically that creates the single clock that's used on the microprocessor as the CPU clock. So if we want to change the clock speed to 12.5 megahertz, let's give that a shot. We would make this a 3, and that's really all we have to do. Let's see if it works. Okay, let's try the same thing with 16.6 megahertz and see if that works. And if it's 16 you leave it at 2, so that should work. Alright, looks like it came up running at 16.6 megahertz. Let's try the same thing at 25 megahertz and see if that works as well. So in this case we have to change both the CPU clock count and the comparison value. Hopefully this will do the job. Well, 25 megahertz did not work. Let's see if we missed something here. Grant says for 25 megahertz, CPU clock count should be 1, and that's CPU clock count less than 1 and CPU clock count less than 1 for the counter halfway. And that's what we've got. We've got the 1 and we've got the 1. So apparently on this EP4 card it doesn't work. I think it worked on the EP2 card that I had. I don't really remember for sure. I'd probably have to go back and test it. But hey, 16.5 megahertz is a lot better than the 1 megahertz CPU we would have had back in the day, isn't it? I'm not quite sure why Grant chose to do the clocking scheme this way. He's doing a clock divider and then he's picking off a particular count for that clock divider, and it seems like that would create an asymmetric clock. Maybe I'll run the clock to, gosh, there's no output pins, but if there was, maybe I can run it to a VGA pin that's one of the very lowest bits, so it really doesn't affect the video. But I'm kind of curious about why he did it that way. Maybe if everything is clocked off the rising edge, it probably really doesn't matter if the clock is asymmetric. But it seems like a single counter with some pickoff here might have been a little bit better than that. I don't know. It's a little bit hard for me to figure that part of it out. I'm sure somebody, again, could leave a comment in the bottom as to why this is a better choice than some other choice. But he's choosing to make the clock swap, and if it's dividing by, if the number here is 2, then it's going to count 0, 1, 2, and then only on one of the 3 is it going to go. But if it's 12.5 megahertz clock, or a 16 megahertz clock, I guess that's 1 in 3 out of the 50 anyhow. So I think we're stuck with that. It's probably tough to make a symmetric clock. Something that would be worth playing with in this part is the PLL abilities of the part, because that in theory could make a clock that's twice as fast and then divide it down by 2 and have a nice symmetric clock. Again, if it's all using the rising edge, it really probably doesn't matter anywhere, but who knows. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.